Yes, welcome back. Welcome back. I would like to appreciate your time, for taking time up to this time. Now, this video is about demo of how algorithm works. In the previous video, we have seen um, how to actually develop this thing, but now we are going to see how it actually works inside the computer system. So, what to take home from the previous video was about the codes. The different kind of the file. We have the source code file, which is the program that you write and save in Java. It will be your class name.java. And then when you compile it using Java Arc, then you get the bytecode, which is a class file generated to create a Java virtual machine, which allows you to run Java on any other platform. It's a platform independent version of Java. And then that Java virtual machine has the capability of changing the bytecode into the bit codes, which is the machine code. And the machine code is full of binary instruction, which comprises of binary digits and hexadecimal. So that's what to take home from the previous video. And from now, this thing can now enter into the hardware and start running. And that's, my friend, what we are going to see. But before that, let us remind ourselves for our model. This is the model. A was the problem, and A new was the function we created, and B is the absolute solution is the expected solution that we are looking for. So this is the setting to solve the previous problem, to turn the background light from red to um, to yellow. So what we're going to do is the input. The input is the problem, which is what we want to do. We want to change red to yellow, right? And then we have the output there, which is about we want to get yellow as our output. So in order to do that, we have to apply different kind of functions, but we have also inbuilt functions in the system. The functions for the input system, this function will now change whatever we are going to give from the computer here. It is the one that actually start diverting where the virtual machines are, to change everything to binary bits so that the processor can start processing the execution. So that's why I wrote here expressions. Now the processor will go through and see how to express what we have programmed in our functions in terms of bits. It will express. That's why all the logical decision making take place here. And there are functions of function within the processor as well. The digital logic, everything. That's why I put this F here for the input device, and F here for processing, and another F there for the output system to receive what has been processed by the processor, and then change them from bit to uh, the actual system, that to the actual result that we want, that can be understood by us. So my friend, this is the setting, and this is what is now happening inside the computer. So the first thing that will happen is for us to uh, to start now running our algorithm. And we have designed our algorithm by using a top-down approach, and then we have selected the the method of implementation to be recursive. So I think I need to define what recursive really means before I go to the next. We are going to dwell on this screen only, but I just wanted to understand this bit by bit. Like, this is our input, which is going to be all those functions all the functions that we have written. Uh, and the function will be processed inside the processor here in order to give our output. But we have written our function to run recursively, which means, we'll explain the recursive situation in the next video. So I thank you for viewing. I hope this video has been informative. What to take home from here is that all the functions that you see here symbolizes the inbuilt function in the processor to change the input into binary formats. and to change it from binary formats to the readable format that we can understand. For example, we want to change this red to yellow. So the function will be applied here on our written input will be the problem that we are we have now defined. We have written function on it. We are going to send it to the system. The system will change it to the bits. And then from there, the logical decision will be made by various kind of expression that the processor will do to kind of like change whatever we want to do with the functions and produce the output. Remember, what processor will be doing is all about the function that we came up with in the previous video. You see, the function will be the system. The system define we define the current system rate, and right. So we need to define to know what rate is in terms of maybe code. We need to do that. So we need to know what yellow is as well, and then we have to have a function that will take A and link it to B, and then the function that will transform, that will be taking place now inside the processor. The processor will be now interpreting our function with its function to do those logical calculation that we have done in the program, to change A to B, to link A to B first, and then reverse, the transformation, reverse the color to make the color of A equivalent to B or B equivalent to A. But we want to achieve B, so we have to make everything to be B. So that's what the system is going to do to match the expected output, which is the color B. And the other function will be to transform the problem completely, compare it at the end, and then give us the expected output. So that is what is going to happen here in this video, in this video here. So the transformation and the logical calculation, everything will take place inside the processor to do those matching, to match A and B, and to transform A from A to B, and then compare the result at the end to make sure we get the yellow color. So that's what's going to happen next. But I told you that we are going to solve this problem recursively. And I know recursion could be something that may be of a new term to some of you, but I will catch you up in the next video and explain what it means.